This is EarthX 2026. I'm Dr. Tracy Fanara. I am here with Amy Polvado. I am so excited to talk to you because you are doing some really innovative technologies. Now, a lot of people don't know what a digital twin actually is,
Right.
but these simulations can really be impactful. Can you tell us a little bit about what a digital twin is and how you're using it to save the world?
Okay. All right. So when no one knows what a digital twin is, I always use this metaphor. So you're Tom Cruise, and you're in Mission Impossible, and you're going in the building, and there's a guy near you going, "Go right, go left. Oh wait, there's people coming around the corner. Go in that vent shaft." Well, yeah, like all the crazy things that Tom Cruise goes through, right? And there's the dude in the van who I gotta remember that actor's name. I always forget it. But he's in the van and he's looking at this model. That's what the digital twin is. It's that model which represents what's happening in real time of a building in a virtual environment. So I'm not sure how that's all movie like, but because in order for
Yeah,
you to get that amount of real timeness, there's a lot of like IoT sensors and camera work
I
and
was
all that
just
stuff.
going to
Yeah,
say that,
yeah.
and just sensors in general,
Just a
right?
sensor in general. So that's fictitious. There's no way they have that like unless they hacked into some of their systems. But but similarly, you can build that out as a real estate owner or property manager and have that level of detail, like know where people are walking, know where, like, depending on using existing systems like cameras and IoT sensors to do some of those things, right? So, yeah.
So you're basically building a computer model. So you're using this for buildings.
Yes, we're using
Okay.
it for buildings, but not only just the buildings, but the infrastructure around the building. So we can, the building plus we can model. So a lot of the industries we serve we do higher education institutions, data centers, a lot of
Okay.
data centers, some hospitals, and the U.S. government. I'm gonna call it DoD. I've known it as DoD like my whole freaking
Yes,
life. It's now
DOW.
it's
Yeah, yeah, yeah.
DOW. Like, okay, whatever, y'all. Like the renaming stuff. Like, chill out, administration. But it's been DoD for my whole freaking life. So the U.S. Army and looking at building out these models for very different use
Yeah.
cases, right? But typically, it's around solving complex problems
Yeah.
that you have to spend a lot of time and manual labor on. And a lot of what people do now is they see AI and they're like, oh, there's got to be a better way. So
Yeah.
that impetus on, I got it. Why am I still doing this via manual labor, and the frustration with having to do anything manually is forcing the adoption of some of these technologies, which is really cool. I will say that we are kind of in the baby stages of all of this, but the ability for a digital twin to do simulations, we use it now for simulations for training for maintenance of buildings. And
Okay.
not only maintenance of buildings, but for operational things, because you need the digital twin to kind of see like an asset, like a big chiller or HVAC unit or whatever it might be. And we can wear the AR glasses, and that person can look at that asset and they can phone a friend, like an expert, to walk them through it. But then they can blow it up and look at it and pull it apart and see certain things in it so they know how to fix it. Right?
Okay.
Yeah.
So it's kind of like with surgeries now.
Yes.
They're kind of doing the same thing. You could
Yes.
be anywhere in the world and do a
Exactly.
surgery on someone because you're controlling the robots.
You
That's
got it.
really
So
interesting.
now they're just controlling another technician. We'll eventually get robots, but
Okay.
right now is we're controlling and we're helping another technician solve a problem. And the AR VR is really good in the fact that that technology exists. Like, you can phone a friend, right? We're adding the extra layer of having a digital twin so that now you can see the asset in 3D, run simulations on so that the technicians understand how the airflow or electricity flow or whatever it is you're trying to solve.
Yeah.
You can run that simulation with those glasses, and not only that, the friend on the other end can look at the same thing so they can solve the problem together. So it decreases times where machines are down, which is really, really helpful to industry. But the digital twin, it it solves more problems around sustainability from you can, using predicting failures of equipment, because equipment, as they start to draw down on life, they use more electricity than they should. So you
Right.
can get better energy usage of what's existing there, but you can simulate all sorts of changes and all sorts of different things. That's the coolest part about it. Well, we use it for digital twins for it, right? So it's great.
That's really cool.
Yeah.
Okay, so let's take data centers because
Yep.
data centers is drawing a lot of attention right now
Yeah.
for the energy and the water. So how can a digital twin or these scenario-based simulations, how can we use that to reduce our impacts on the environment?
So we use digital twins from the very beginning. So when you're designing the data center on how much power it's going to use, so a lot of people now are doing behind the meter power generation. So not only are we modeling the data center, we're modeling the power generation too, and the power quality, energy flow, all that other stuff that's happening in the data center. You can also model the water flow and all of that. So they're using it early on in design to tinker, right? So when you're, what's happening in the data center industry is crazy town. You're going to get, even when you're under construction, your customer is going to come to you, I need to change all of it. And so you're going to have to go, oh, we have to add footprint, or we have to do this, or we're
Yeah.
changing our rack densities, or we're doing that. So the only way you can change that without major construction delays is to use a twin to run a simulation to go, hey, all right, we need to change this. They're coming at us with this. How do we do that? This is our existing footprint. Let's run a simulation on what that looks like.
Yeah.
What are we going to have to do? So we're building out a simulation for that very purpose alone. So like do these on the fly design changes and all these other different things. That's one use case. Once you have the model built, what we're really trying to do is take it from dirt to commissioned operations. So dirt, you can use the simulations to do a lot of different things. As it's being built, you're building a digital twin of everything, so you truly have a true as-built. It was because the plans aren't it. I was in construction forever and a day. I did not build 100% to what was on those plans, y'all. Like it didn't happen. Like crap happens in the field, and so. But if you have a true as-built of exactly what we built, where those electrical lines are, so you don't like cut into them and kill yourself, where all this stuff is that's behind a wall that you can no longer see. If you have a true as built, that's great. And then that leads into commissioning of the data center, and there's use cases there. And then from the operation, so you can truly have a good life cycle of the entire asset from dirt to commissioned operations. And we're finding places to insert ourselves. Like it's so early and so new.
Yeah.
So using the AR glasses and training, you can do that with the data center technicians. You can do that with all the construction crews along the way. You can do that in lots of different areas. But taking over, what we're finding a little bit of head blocks or whatever, roadblocks, is on the commissioned data centers. Those are difficult because they have agreements they have to meet. They have all sorts of different things. Going into an already built data center with no digital twin and coming in to do a digital twin
And then do a retrofit.
and yeah, or whatever it might be. You can do it if there's a use case, like if they're switching over from a normal data center to an AI data center. That's a great use case for a digital twin, right? You can tinker and run simulations and do all sorts of things, right? Build it in the virtual environment before you do it in the real world, or you're guessing based off of an architect's drawing. So that's a really good use case. But on an existing AI data center that's already built, say it was built like 3 or 4 years ago, where they already have agreements in place with all of these off takers or whatever, you got to get all of those people to sign off that we're going to come in and model this all out and agree to it. The industry is very control freakish. So we're finding a little resistance there. But Jensen Huang, who is the CEO of NVIDIA, is the biggest digital twin cheerleader
Right.
I have ever met ever.
Right.
And I don't have to do much because the only reason people know about digital twins is because that guy's out there going, go digital twin, go. Like, and I'm like going, go Jensen Huang, go. Like, this is awesome.
Yeah.
So he's doing a lot of our marketing for us. So yeah.
Yeah, that's pretty amazing. So has there been a pilot project that you've seen? Like what kind of benefits has the digital twin really given companies?
Yeah. So so on some of our early pilots, and we're still collecting data. But so the biggest drawback or the biggest risk to any data center is downtime, right? They're losing millions of dollars when they're down, right? And the most risk to downtime, like 80% of those errors are human. Like some dude left the ladder in front of the air vent or what, something else, like the heat exchanger or whatever, and they're burning up a server because they left a ladder there. Like
Oh, geez.
simple things, right?
Right.
So it's real simple things. So eliminating those mistakes is what we're uber focused on. So some of our pilots are early focused on that, and it's via training, it's via remote monitoring,
Yeah.
it's those kinds of things. So we're seeing a reduction in that. They're all early pilots. So I will probably, if you ask me that question in 6 months, I'll have a really good answer. But early on, we're seeing like reduced incidents in downtime.
Yeah.
About like 30 to 40%, which is
Wow.
really cool. And I think we'll have better use cases around PUE and WE, which is water and power usage efficiencies. But I don't have enough data for that yet.
Okay.
Yeah.
It's super interesting. You said something really, really important. You were talking about how when a data center is already built, how difficult it is because you need to get all these people to approve.
Yeah.
I've noticed in my entire career how hard it is for people to fix something that isn't broke.
I know.
You know what I mean?
know.
And I mean, I've seen it in low impact design, retrofit. Like the answers there, so the solutions there. It's not a Band-Aid.
No.
It's a big change,
Yeah.
but it's worth it in the long run.
Right.
You'd have to determine where your effective point is. And the problem is that those people probably making those decisions have a term that's shorter than where that effective point is.
Yeah. I think digital twins will resonate with them because you can get those returns quicker. Like they're going to see it and they're going to feel it a lot sooner. But yes, that is the age-old problem.
Yeah.
Is adoption when it's not broken. We're not going to fix it. I think there's so much external pressures right now in the data center industry from the communities, which, by the way, they have a lot of bad information about how AI data centers are being built. But nonetheless, there needs to be, and the industry in itself feels that from the community side. So they need to be able to be a little bit more transparent about their water use and about their power use so that people can see it. They don't. And I think a digital twin solves that problem for them. I mean, they can say our design is to do so many gallons of water a day, and then we can show you our water bills, and that's fine, and we can show you how much usage we have. But I don't think the whole systems of data centers are designed in a way to where they're kind of difficult to track. Like, so you can be at some point water positive.
Yeah.
Like if you do a closed loop cooling system on a data center, so as soon as you charge it up, and it's not with water, by the way, it's with like glycol solutions you buy from Exxon, or it's with gray water, but it's all mixed. Like it's not just water, but you can charge those systems, have them up and running, and use heat exchangers on the end. You can actually make water from heat that comes off the data center and comes off the power gen that you basically give back to the environment. And so now you're water positive. And so, but that whole system is very difficult to integrate to show the community unless you have some sort of model that can put it all together. You can do it. It just takes a lot of time to do.
Yeah.
So you can integrate it all together in a really cool way to show a community like, hey, yes, we had initially a 2 million gallon water and glycol charge of the system. Once it's running, we're good. The only water we're pulling off is for the bathrooms because people have to, go to the bathroom or the break room. But other than that, we're not using a whole heck of a lot of water. And not only that, this is the amount of water we're actually producing, and you could show that. I think it's a really cool thing.
Yeah, it seems like water treatment could really be optimized. Was that hydrolysis that the water molecules after vaporation?
Yeah, so what
vaporization
they do,
comes back together.
Yeah, so you can use on the power gen side that especially a lot of the data centers are now doing behind the meter on-site power generation. All of them are. Like 80% of data center developments going forward are doing it. They can't connect to the grid in any reasonable amount of time. Like if you go to ERCOT, there's 460 gigawatts sitting in the interconnection queue. A lot of that is from data centers. So we're not going to get any power anytime soon because they got to figure themselves out. In some of the regions that we are doing projects in, I've been told, we'll get you connected to the grid in 10 years. Like, no joke, 10 years. And so we're like, okay, well, that's not going to work. So we're going to build our own power, and then eventually they'll come knocking. But when you do that power gen, that and the data center, you can take that heat and you can use it to create power.
Right.
You can use it to create water.
Yeah.
You can stick it in a greenhouse, but in Texas we don't need greenhouses because we're freaking hot. But you could use it for lots of different reasons, right? And we're looking at really cool ways on ours to do carbon capture off of the power gen.
Yeah.
To reuse it in concrete and other building
Yeah.
materials and find really good ways to be really good. I think that the data center industry as a whole has always been a good neighbor. People don't believe us at all, but they've always, like, the water, a good friend of mine has been building data centers since like 2008. And he told me, he's like, Amy, the water that used to come into my data centers was dirtier than it left my data center. Because we filter out all that kind of stuff. We make sure that there's a lot of, like, you can't have dirty water going in through a data center. So he goes, it was always like that. He goes, it's always been like that. The industry's always been very, very good. We just get a bad rap. And so I think it's hopefully getting better as we educate more, but it's a political year.
Yeah.
So there's going to be a lot of talk, but that's okay. I think the industry needs to do a better job of not, being a black box with information, be a little more transparent.
Yeah.
And I think if they do that, I think the conversation changes for sure.
Yeah, it seems like most things come down to communication and
Yep.
education,
Yep.
in addition to the technology, because the technology won't have legs without the other two pieces.
For sure. Yeah. And AI is enabling a lot of the green improvements data centers have to make, because you cannot cool a data center using evaporative cooling. An AI one, you can't use. And evaporative cooling did use a lot of water, but still,
Right.
It's like, be real, it did. I'm not saying that we didn't, but any AI data center, like the stuff that NVIDIA is creating now, you have to liquid cool it. You have to use a closed loop system. And now we're doing not only one loop for the IT, you're doing another loop for the power gen. You're doing 2 or 3 loops depending on where you're at. So everything is closed loop, so it's self-contained. I think it's getting really cool at how good they are about using water, and then how good they will be about using power.
Yeah.
Yeah.
So the thing that I love most about space technology, like I'm an environmentalist, so
Yeah.
so it was really strange when people started hearing me doing stuff with NASA.
Yeah.
And really space is for Earth. You have this self-contained, like, the rocket,
Yeah.
that you reuse everything. You can't waste
yeah.
anything. Like, here on Earth, we have the luxury of waste. So NASA water treatment systems, energy systems, all of that has to be completely reusable.
Yep.
And I really would like to see the combination, and it's probably already happening right now. You're probably using stuff that was originally created by space industry.
Oh yeah, for sure. So I chair the U.S. PropTech Council, which is the trade association for the real estate technology industry. And we've had at South by Southwest, and as part of New York Tech Week, we had that very topic of how are we taking space tech and then using it here on Earth.
Oh, I love that.
Yeah.
Okay, so
yeah.
same. Yep.
Yeah, exactly.
Yep.
And we've had guys that came from SpaceX, came from NASA, talking about, oh yeah, we had this cooling technology and now we're seeing it applied here. We've got robots and robotic arms and drones and different things that you use in space that we wouldn't necessarily use here, but now it's being applied here because it has really cool uses.
Yeah.
So there's like Earth moving equipment that's completely operated by AI. It's all robotic. There's no operator, and it goes out. And this is a former SpaceX engineer.
Yeah.
And he was building out this similar thing. They were like, oh yeah, we're gonna have to get to Mars, so we're gonna have to build on Mars.
Right.
So we're gonna need robots in order to do that. But there's gonna be nobody driving on Mars.
You're going to need a digital twin of Mars.
Yeah,
You
exactly.
just are.
I know. It's going to be really, really interesting. But did you see Mr. Musk and his announcement about the terafab and what they're trying to do with the moon? Did you watch that?
No.
Oh, you got to watch it.
Okay.
So it was insane. First of all, it's a really long video, but it starts at like he starts talking at 21, but he's using the moon as a launching pad for like, so we go to the moon, we colonize or hang out at the moon because there's less gravity, so you can like launch stuff
Right.
like it's a spaceport, and so you can hang out at the moon, and so you can launch out all this compute and data centers in space, but you do
Yeah.
it from the moon, not from Earth.
Oh, right, right. Because so that was the whole thought behind, you know, getting to Mars, to use the moon first.
Yes, yeah,
Because of
exactly.
that.
Yeah,
And yeah, it's going to be really interesting to see how all of these technologies
yep,
start feeding each other.
yep,
And the important thing is going to be that people are connecting.
yeah, 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 yeah.
You know, connecting their ideas, like diverse ideas. And here at EarthX, like that's a great opportunity.
Oh, for sure. I mean, I was talking to a marine scientist, and we were just like, we were in the speakers lounge and we were chatting, and I was like, oh, wait, but that has applications over here. And that's like really cool. So if you did this, so if we talked about how we can use the oceans in really cool ways to cool the earth,
Yeah.
right? And that has impact on land because we
While
have these
reducing the
buildings.
temperature of the oceans.
Yeah, exactly. And so you're reducing overall you're cooling the earth. And so we don't need to spend as much in energy on land to cool our buildings. All for it, man. Let's
Yeah.
do it. Like I think all of our systems are integrated. That's why I love this conference. I was like, I get to talk to people from all different things, and like, oh well, that completely has applications in real estate, right?
Right.
Like you wouldn't necessarily think that, but it does. So space does, the oceans do. Like how can we cool the earth so that when us as building owners or developers can make really good decisions about, oh well, we're not going to have to spend as much
Right.
on cooling, or maybe we can find other ways to do that, or maybe we can have robots that hang out and, you know, they're looking at doing that now. The robotic technologies will be introduced, and they already are in data centers, but also in regular real estate.
Yeah.
And that all came from space stuff.
Yeah. Well, it has been amazing talking to you. We could probably talk forever,
talk forever.
and go on all
Isn't
these
there?
different
I
tangents.
know.
But thank you so much for the work that you're doing. I'm
thank
super
you.
interested to see and read your dissertation
Oh, yeah.
and to follow your company.
Oh, thank you. I appreciate for having me.